Yes, dear children, moving further, let us try to revise what is nucleophilic substitution. It is of two types, SN1 and SN2. This you know it already. One represents unimolecular, two represents bimolecular. Okay. Now this SN1 reactions, it is carried out in the presence of polar protic solvent. Polar protic solvent. Protic means anything which has H plus ion in it. Okay. So water, ethanol, acetic acid, they are all called as polar protic solvents. Okay. Now, in the case of SN2, this takes place through a transition state in which both the reactants and products, both the reactants are bonded to each other. Okay. This we will see one example and try to understand that better. Okay. You can see it here. Now here, this is the reactant. Okay. CH3Cl I have taken, and OH minus is the nucleophile, and this OH minus is attacking the carbon and it is forcing the Cl to leave as Cl minus by taking this bond pair. So initially in the transition state, both OH, that is the incoming nucleophile, and the leaving nucleophile, both are attached to the carbon. So this is what is called as transition state, and then this Cl leaves as Cl minus and OH sticks to it, or OH is attached to it. So you'll get methanol as a product and Cl minus leaves the molecule. Okay, so this is your SN2 reaction where the reactant and the incoming nucleophile both are reacting in a single step. Okay, so that is why it is 2. Now, SN1 reaction, it follows first order kinetics. This one represents unimolecular, so it is following first order kinetics. That means the reactant molecule is only one. This follows second order kinetics, and that is why it is SN2. Okay. Now here it depends on the concentration of Rx alone, because it's the property of Rx only we are seeing, is it not? So which is the reactant? Reactant is our alkyl halide. So it depends on the concentration of Rx alone. Whereas in the case of SN2, it depends on the concentration of both alkyl halide as well as the attacking nucleophile. Then SN1 reaction occurs in 2 steps. First step is formation of carbocation, and then second step is attack of nucleophile. Okay. This formation of carbocation is the rate determining step, and the attack of nucleophile is the fast step. And here it is occurring in a single step. Just now I showed you. Then SN1 reaction, the order of reactivity is tertiary greater than secondary greater than primary. Why tertiary is having the highest reactivity? Because formation of carbocation, you know very well that tertiary carbocation is more stable. That is why tertiary alkyl halide will show SN1 reactivity to maximum extent, right? Whereas in the case of SN2, the order of reactivity is primary greater than secondary greater than tertiary, because this SN2 reaction, it is based on steric hindrance, bulkiness. Okay, so next point is that only it depends on bulkiness or steric hindrance. That is why primary is more reactive in SN2. Primary may there is least steric hindrance. That is why the reactivity is more. Whereas here it is tertiary because it is based on the stability of carbocation. So tertiary is having greater reactivity. Then it depends on stability of carbocation. Obviously, tertiary carbocation is more stable. So stability of carbocation is a very important factor when you decide the reactivity through SN1 reaction. Whereas here it is depending only upon steric hindrance. So this is a brief idea about your SN1 and SN2 reaction. SN1 means substitution nucleophilic 1, which is involving only one reactant. Here it is involving 2 reactants. Okay, now let us see the mechanism. First step I told you, it is formation of carbocation. I have taken a tertiary halide. In the slow step, what happens, because these CH3 groups, they are all electron releasing in nature, it favors the Br to leave as Br minus, so that a carbocation is formed. Okay. Second step is the attack of nucleophile, where the incoming nucleophile, say it is OH minus, it is attacking the positively charged carbon and it gets attached to it. So this is your fast step. So the energy needed for the cleavage of CBr, this CBr has to be cleaved, is it not? So this energy to cleave this bond, to break this bond, is obtained through solvation of the bromide ion with the proton of the protic solvent, right? The Br minus, it is surrounded by the polar protic solvent. If it is surrounded by water, okay, this is what is called as solvation. So that's why he's telling the energy needed for the cleavage of CBr is obtained through the solvation of the bromide ion, through the solvation, interaction of water with Br minus. This interaction is something like bond formation, and any bond formation is exothermic. Exothermic means energy is released and the system receives a greater stable state. Okay. Low energy state is more stable state. Remember that. Okay. So that is why polar protic solvent is required in the case of SN1 reactivity, and the reactivity is tertiary greater than secondary greater than primary. Whereas in the case of SN2 reactivity, just now I discussed with you the mechanism. The attack of nucleophile occurs from the backside. It is attacking the carbon from the backside, and the leaving group leaves from the front side. Okay. And SN2 reactions are always accompanied by inversion of configuration. Are always accompanied by inversion of configuration. Why it is inversion of configuration? Look here, where the Cl was initially, it was to the right of carbon. Okay. Now look at the incoming nucleophile, where it is attached in the product. It is attached to the left of carbon. Okay. So this is what you call it as inversion of configuration. Okay. Just like an umbrella turning inside out in a strong wind. This is what is the comparison. So this inversion of configuration is also called as Walden inversion. And in the case of SN2 reactivity, it is always primary greater than secondary greater than tertiary. So this you have to understand very clearly. Right. Now, like tertiary halides, allylic and benzylic halides, they also show high reactivity towards SN1 reaction. Why? Because allylic cation, it is more stable by resonance. Same way benzylic cation is also more stable by resonance. Now here I have shown you how an allylic cation is produced. Now this carbon which is having a positive charge, that was holding Cl. You know very well, allylic halide mein the carbon holding halogen is sp3 hybridized. Okay. So after the loss of Cl, this will be CH2 positive. Now this is undergoing resonance. See here, this bond is shifting over to this position so that it can neutralize a positive charge on this. So when this is shifting, this carbon will get a positive charge. Okay. And the double bond is shifting to this position. So here there is a double bond. So this is resonance. Same way in the case of benzyl cation also, the CH2 benzyl carbon is holding a positive charge, and so the pi bond from the benzene ring is getting shifted towards the CH2 group to neutralize the positive charge on this. So when this is shifting, then there will be a positive charge here, then this will shift, then there will be a positive charge here, then this will shift, and there will be a positive charge here. So that is what is shown here. So there is resonance stabilization in both allyl cation as well as benzyl cation. Okay. So for a given R group, the reactivity of halide follows this order. What is the order? Ri greater than RBr greater than RCl greater than RF. Why? Because the size of I is big and it is less electronegative. Okay. And because the size of I is bigger, the bond length is larger, so bond dissociation energy is smaller. Okay. So larger the size of halogen, lesser the electronegativity of halogen, lesser the bond dissociation energy, better the leaving group. Okay. So these are key words. So you need to understand all this clearly. Now based on that, there are a few exercise questions which you have already seen. Now here you see this is primary carbon, whereas this is secondary. This is attached to this carbon and this carbon. So this is secondary. Okay. So which would undergo faster SN2 among the pair? Now SN2 mein kya hai? The reactivity is 1 degree greater than 2 degree greater than 3 degree. Okay, this is secondary, this is primary. So this will undergo SN2 reactivity less and this will undergo faster. Same way, in the second case, this is Ci bond and this is CCl bond. Yes, now which will easily break. Ci bond dissociation energy is less, so if this is associated with a better leaving group, so this will be reacting faster. Same way, predict the order of reactivity for 4 isomeric bromobutanes, C4H9Br. You have to write the 4 isomers. What are the 4 isomers? सबसे पहले वो समझ लो. Br attached to the first carbon. Br again attached to the first carbon, but the length of the carbon chain is different. It's a 4 carbon chain. This is a 3 carbon chain with a branch at the second position. Then you are having bromine attached to the second carbon, that is secondary. Then bromine attached to the carbon, which is tertiary. Okay, so these are the 4 isomers. What are the isomers? N-butyl bromide. This is isobutyl bromide. Try to recollect your memory how you used to write butane and isobutane. Okay, butane was a simple 4 carbon chain. Recollect your memory. This is N-butane. What is isobutane? Isobutane is 2-methyl propane is isobutane. So the corresponding isobutyl group will be 1 hydrogen short. So this is isobutyl group. So isobutyl bromide, then sec-butyl bromide and terbutyl bromide. And the order of reactivity, if it is SN1, this is the order. If it is SN2, this is the order. Right? Same way you have another NCERT question. It's a worked out example for you. Again, here also you have to tell the order of reactivity in the case of SN1 and SN2. Now here it is primary, here it is secondary, here it is again secondary, here it is tertiary. Now both are secondary, right? But then there are 2 benzene rings here, but here there is only 1 benzene ring. Where there are 2 benzene rings, there is more of resonance stabilization. So resonance stabilization की वजह से कार्बोकैटायन स्टेबिलिटी ज़्यादा है. कार्बोकैटायन स्टेबिलिटी ज़्यादा है तो SN1 reactivity इसमें ज़्यादा है इससे. ठीक है? So based on that I have given you the order. Go through it. Then which will undergo faster SN2? Again the same way. This you can try and do yourself.